For the next problem, we'll look at a number written in scientific notation. In 2007, world population was approximately 6.6 times 10 to the ninth. By some projections, world population will double by 2040. Express the population at that time in scientific notation. Well, since the population's going to double, it will be double what it was in 2007. So we can say the new population will be 2 times 6.6 times 10 to the ninth. In order to figure out what this is, we first multiply 2 times 6.6 and we'll end up with 13.2 times 10 to the ninth. Now be careful, because although it might seem like it's in scientific notation, it really is not written in scientific notation. In order for a number to be written in scientific notation, it has to be of the form a, some number, times 10 to a power r, where this number a has a restriction. 1 is less than or equal to a is less than 10. So we see that this number a has to be between 1 and 10, although it could equal 1, it has to be less than 10. Well, RA is 13.2. That's too big. So we need to rewrite it so that it's between 1 and 10, could equal 1, but has to be less than 10. So we simply have to move this decimal point around. So notice if we move it one place to the left, we'll get 1.32. We can't arbitrarily do that though. This 1.32, we really made 13.2 smaller by a factor of 10. So in order to balance it, we have to multiply it by 10 to the first power. Now all I've done is I re-represented 13.2 as 1.32 times 10 to the first. We still have this times 10 to the ninth. Now I can write my final answer. I can write the 1.32 times, I have 10 to the first times 10 to the ninth. Remember the rule for multiplying like bases, we add those exponents. So it's 10 to the 10th. So we can predict that the population in the year 2040 will be 1.32 times 10 to the 10th.